In this short video, we will try to explain how Phi handles edges and what tools you can use to give them the shape that you want, using a couple of simple examples. So here we have a simple cube, and all of its edges are linear. We know that they're linear for two reasons. First of all, we notice the bright color on them, which indicates linearity. And secondly, if we select them and look at the linear button at the top of the screen, we notice a yellow ball on top of it, which means that this is active, so therefore linearity is enforced. And indeed, if we move the vertex around, we notice that the shape of the edges remains linear. Now, how can we change this and make the edges be non-linear? There are two ways to do it. First of all, we can select them, and then we can click on the linear button, so the linearity is no longer enforced. And if we then move the vertex, we notice that the shapes of these edges will deform. And this deformation is calculated by Phi based on the original shape, the movement we do, and also any other constraints on the edges, and currently there are no such constraints. Another way to make these edges non-linear would be to directly click and drag them. So here I am directly deforming the edges and the linearity is no longer enforced. Now, as we mentioned, we could have additional constraints. So here I am popping out this face, I select this part of the body and I fix it. And then I select these two edges, and by clicking on the tangent button up there, I will ask for those edges to become tangent. And we see the deformation, and whatever I do to the edge, the tangency constraint will be respected. Now, Phi allows us to do quite extreme deformations to our edges, and it's quite easy to get into shapes that are probably not what you were looking for. But it's easy to simplify the shapes of your edges by using the fairing command. So I select this edge, and I repeatedly click on the Fair button, and with every repetition the shape of the edge will become simpler. And in fact I can set a strength for this fairing command through the Preferences menu. It was on strong, now I switch it to regular, and I repeat what I did before, and we see that with every fairing step the shape of the edge is simplified. And in the process any constraints on it, for example the tangency we have set at the right side of this edge, will be respected. And you can also select more than one edges, like these two edges here, and fair them together as one. So Phi treats them as if they were one single edge and applies fairing to both of them together to give an overall simpler, smoother and more elegant shape. And one more example, I have two rectangular blocks here, everything is linear to start with. I select the top face of this block, I hit M for the move manipulator, and I click on the axis to ask to rotate it by 90 degrees. So you see that as the top face rotated, the edges remained linear, but of course the faces between them deformed. They are now transparent to allow us to see the edges better. Now if I do the same on the other block, where I rotate the entire top part by 90 degrees again, we notice that the edges did not remain linear, they deformed. And the reason is that we had asked for these edges to be tangent both to the top and the bottom blocks of this body. So the only way to maintain this tangency was by deforming the edges. If I now make these faces non-transparent, you can see clearly how the face is deformed, but in one case the edges remained linear, whereas in the other block the edges deformed to respect the tangency on both ends. And one last example, we have three cubes, everything is linear, and we are pulling out this square on the top face of the cube. As you see, the edges moved to follow the movement of the square. And we're now creating another square through an offset command, and we're also pulling this out similarly. So everything remains linear as expected. In this second cube now, we do something different. We start with an offset within this square to create a second square within it. And now we select all of the inner faces of this square, and we pull it out. And we notice that the edges are no longer linear. The reason for this is that Phi assumed that the user wanted these edges to remain tangent, as they were in the initial shape. So if we undo this operation, and then we select this pair of edges, we see that they were marked as tangent. And if we also select the other three pairs of tangent edges and remove the tangency from the top menu, and then repeat the move operation to pull the square out, like we're doing here, we notice two things. The edges are no longer tangent, however we still get a deformation of the edges that moved, and the reason for this is that The initial tangency meant that we don't expect the edges to remain linear any longer. What we can do, of course, is select all of them and hit the linear button like we just did to make them linear. And now a third example. Again, we select this face and we offset it to add the second square in the middle. We select everything, all of the square faces, and move them up. And we see the deformation due to the tangency like before. And we also select the middle square and we move that up as well to get a double deformation due to the tangency between those pairs of edges. Now we understand that this may not be the result one expects, although from phi's perspective it makes sense. But here's how you can work with this and bring it in the shape you want. So in this case I'm selecting the lower part of the body and fixing it so it won't move. And then I select these pairs of edges with a shift click and I go in hidden edge mode to select the rear one. I then set the smoothing strength to regular and I will do a fairing of these edges. So the fairing command simplifies the shape of these edge pairs that we selected. I now undo and I select these four pairs of edges to make them tangent so that they will smoothly follow the shape of the lower part of the body as you see, and I will repeat the fairing. And in this case you will see that the resulting shape from the fairing will respect this tangency and will give a simplified result, bearing in mind that the edges need to remain tangent to the lower part of the body. Now I can go back to my initial cube and also select these four chains of edges all along its height and also do a fairing operation here. And again you will see that these linear edges are now deformed to give an overall smooth shape. In fact, we notice that the top part of the pyramid is now pinched because this loop of edges that was perpendicular to the faired edges got deformed. So I simply turn them linear again as they should be to give the result that we want. Now I will undo again and I will try something different. I hide everything except all of the vertices of the shape just for convenience. I select them and I fix them. So now we'll see how we can fair edges, edge chains like I'm doing here, and keep the vertices between them fixed. And you see that the result is again a fair and smooth shape, which respects, however, the position of all of the vertices. I have switched to a strong weight for smoothing to get a more pronounced result. And I'm now doing the same in this shape here. And you will see that that phi will find a shape for these edges that respects all of the conditions, fixed vertices, tangencies, and also gives a shape that is as smooth and elegant as possible. So this was to show how phi handles edges and how operations such as the fairing operation can be used to obtain the results that you require. Thank you.